Pucker stats to wrap up 9.1. Sometimes you want your error to be a certain amount or less. So now what we need to figure out, sometimes because you're going into running some kind of experiment and you're going in, you know that you need to be accurate to a certain degree. So you need to know how many people you need to sample in order to get at a certain level of accuracy based on your confidence interval. So what do we have to do here? Well, if we solved that equation for n, this n equals p hat times 1 minus p hat times z alpha over 2 over e, our error squared. Well, that's the exact same equation we just had. Remember, error was equal to z alpha over 2 times the square root of p hat times 1 minus p hat over n. If we try to solve for n, what we're going to have to do is divide the z alpha over 2 to the other side. How do we get rid of a square root? We square. If I square both sides, I get error squared over z alpha over 2 squared equals p hat times 1 minus p hat over n. Now, if you have two fractions that are equal, you can flip both sides, which means my z, I'm just going to label it z for now, over error, both of them squared, equals n over p hat times 1 minus p hat. And to get n by itself, I need to take this denominator and multiply it to the other side. So that's how they get the function. It's essentially the same equation, we just have it solved for n. So sometimes you know the error ahead of time that you're going to have to be accurate within. This is usually particularly valuable polling places for like elections, things like that. So the formula uses p hat, which depends on n. It's the thing we are trying to find. So two possible solutions are use an estimate of p hat. So if someone has done the study previously, you can use their p value as p hat. The alternative is let p hat simply be 50% or 0.5. Because when you multiply 0.5 times 1 minus 0.5, that's the biggest it can ever be. So regardless of what the number actually is, that covers every base, regardless of what p ends up being. So it saves you the time and energy and say, hey, if you get this accurate, it doesn't matter what p is. It will be at most this many people. So let's talk about how this actually works. Now, one thing to note is our error is again in decimal form. So sociologists wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 95% confidence, assuming she uses the 2000 estimate from the census stating that this number was 82.4%. Okay, so it says n equals p hat times 1 minus p hat times c alpha over 2 over error squared. Now we know p hat is our given previous number, so that's the 0.824. If you take 1 minus that, you get 1.176, or 1 minus p hat. Now, this is 95% confidence interval. This is where we use our critical value for 95% confidence. If you look back a few pages from the last video, this is 1.96. Her error is 0.03, 3 percentage points squared. Let's see what this is equal to. When you multiply these all together in the calculator or Google, you end up with 619 point something. You always round this up to the next person. If you round down, there's a chance your error could be slightly bigger than 3%, in worst case scenario. So you always round up to the nearest number for n when you're doing this. So 620 people need to be sampled to be sure you're within 3 percentage points. Now, this was when we know that 82.4% was the number previously, so we're using that thinking it's pretty reasonable. What happens if there was no previous study? What if she wanted to determine the percentage and she didn't have anything to go back on? So what we said is, if you don't have anything to fall back on, if you let p hat be 0.5, you're guaranteed to catch any point estimate, population proportion, and still be fine. So instead of having our 0.824 and 0.176, it lets both of the numbers be 0.5. That's 1.96 over 0.03 squared. Now what you notice is if you put these in the calculator, this ends up being 1,068. 1,067 point something. This is a pretty big increase over 620 because, again, the more one-sided it is, and 82% is pretty one-sided, the fewer samples you're going to need. So just keep that in mind when you're working on the homework problems, and that is all for 9.1.